Hello everybody. In my video, I'm going to be discussing Coulomb's law and atomic periodicity. So first things first. Coulomb's law is a law of physics that describes the electrostatic attraction or repulsion that two charged particles exhibit. In other words, Coulomb's law describes the strength of attraction between two particles and the distance between them. You'll be seeing a lot of Coulomb's law into play in the next periodic trends I will be talking about. The first periodic trend I will be talking about is atomic radius. Atomic radius is the distance of an atom measured from the center of its nucleus to the very outermost electron shell. The radius of an atom tends to grow down groups due to the additional electron shells resulting in greater electron shell shielding. And also, the radius also tends to grow left across periods because of additional electrons, resulting in a lower effective nuclear charge. Here is a graph depicting atomic radius. As you can see, the atomic radius will decrease going from left to right because of an additional proton added, which will attract the electrons and will decrease the size of the atomic radius. And also, you can see that there is a peak at every new period because of a new electron shell being added, further increasing the atomic radius because of the inner core electrons shielding the new shell. Alright, on to electronegativity. Electronegativity is described as the tendency for an atom to attract an electron pair. Electronegativity tends to increase up groups because of a more effective nuclear charge due to a lower number of electron shells. Electronegativity tends to increase right across periods because of an increased number of protons increasing the charge of the nucleus. Alright, here's a graph that is showing electronegativity increasing right across periods and up groups. Alright, on to electron affinity. Electron affinity is the energy change correlated with the gaining of an electron to a gaseous atom. Electron affinity tends to increase going up groups because of a smaller amount of electron shells, therefore creating a greater effective nuclear charge. Electron affinity tends to increase going right across periods due to having a nearly complete electron shell. Here is another graph depicting electron affinity. Alright, on to melting point. Melting points are the energy it takes to change a solid to a liquid. Melting points are directly related to the attraction between atoms or molecules. Metals typically have a high melting points, whereas nonmetals have low melting points. The next trend is metallic character. Metallic character is the readiness for an atom to lose an electron or ionize. Metallic character tends to increase down groups due to a larger electron shielding effect, increasing the atomic radius and making atoms more likely to ionize. And they also tend to increase left across periods because of a lower amount of protons, creating a positively charged nucleus and lowering the effective nuclear charge, therefore allowing the atom to ionize easily. Now we're going to do some practice problems. A. Which of the following elements have the lowest electron affinity, and explain? Fluorine, chlorine, bromine, or iodine? B. Each of these elements can form an acid. Write a balanced chemical equation for each reaction. I. Which would be the strongest acid? Explain. C. Which of the following salts will have the highest melting point, and explain? Here are the answers to the practice problem. A. Iodine will have the lowest electron affinity because of the 5 electron shells that surround it, shielding the positive charge of the nucleus. B. The reactions are listed below in order. I. A strong acid is an acid that will dissociate 100% in water. Because of iodine's relatively low Coulombic attraction with hydrogen, the hydroiodic acid will have the least attraction between atoms, therefore dissociating the best. The sodium fluoride will have the highest melting point due to the strong Coulombic attraction between sodium and fluorine due to their very small atomic radii compared to the other compounds. Alright, well that was it. Thank you very much.